All right, I'm going to go over a couple of the bonus questions that we had on the test this past last Thursday on September, I believe it was 24th, Thursday the 24th. That doesn't really matter, but we had two bonus questions. One of them was, how can you construct a 30, 60, 90 triangle? We have constructed equilateral triangles, which are, we know that all the sides are equal and all the angles are 60 degrees, but we did not construct a 30, 60, 90. Two of the triangles we're going to be looking a lot at in this course, and you'll continue to look at as you go in math, are 30, 60, 90 triangles and 45, 45, 90 triangles. The numbers refer to the angle measure. So the way you can construct a 30, 60, 90, the first thing, and I'm going by the fact that we know how to construct an equilateral triangle. So the first thing I would do is construct an equilateral triangle. After you do that, now you need to somehow get a triangle or somehow get an angle that's 90 degrees and one that's 30 degrees along with a 60. Well, equilateral triangle already has one that's 60 degrees here. How, how are we going to get a 90 degree angle though? Well, the construction that we've done that gives or will produce a 90-degree angle is a perpendicular bisector. So if we do a perpendicular bisector of this bottom side, you could actually do any side, really, it would not matter. But if I do a perpendicular bisector of that side, I will create a 90-degree angle. Then I could go up top here and do the angle bisector, which would produce remember that cuts the angle in half, which would produce a 30-degree angle. In this case, the perpendicular bisector of a side of an equilateral triangle will also bisect the opposite angle. So when you do that, you will actually not only cut this in half and produce a 90 degree angle, but you'll also cut the angle up here in half if you do it correctly. And I say that always because you're dealing with tools that are sometimes inaccurate, hard to use, even when I'm on the computer. It's even more difficult for you guys, the students, with those compasses you guys use, not being sometimes that accurate or difficult to use. But the construction, if it is done perfectly, your perpendicular bisector should go right through the middle. Now mine's pretty good right here. So I'm gonna move this, and that's pretty good. All right, so what you have now, if I were to label this A, and then B, and then C, triangle ABC at this point, ABC here, and I'll put a point here. Triangle ABC now is a 30, 60, 90 triangle. This angle up here is 30 degrees because we cut a 60-degree angle in half. This angle at B is 90 degrees because of the fact we did a perpendicular bisector. We know that that's 90 degrees. And A is 60 degrees because it is still part of our original equilateral triangle. So that gives us a 30, 60, 90 triangle, ABC. All right, I'm going to look at the next one. All right, we're moving on to the 45, 45, 90 triangle. Now, there are multiple ways to do these constructions. However, one way to do it would be to construct a square. And the one way we've learned to construct a square is inscribed in a circle. So what I did was create a circle. Remember, that was the first step. I created I just drew the diameter, which had to go right through the center point. I did a perpendicular bisector, and now I've successfully cut the circle into 4 equal sections. So 1, 2, 3, 4. Now, if you guys remember, I'm going to take away these right here. What you do is connect the 4 points here. And you have a square. Like so. Move this now, and I'm going to group this just so I can deal with this by itself. Group it, Alright, so now we have a square. Now, the thing about a square that we know is we have 90 degrees on each corner. So if I were to, how am I going to get a 45 degree angle? Well, we've talked about doing the angle bisector. So what I could do is cut one of these angles in half. Again, if we do this correctly, once we do this angle bisector, now you might think, well, I need to do the angle bisector here and I could do it up here. If we do it correctly, we should have a line that goes right through the diagonal. We should have. Again, we're dealing with tools that are not exact, so we're going to see what happens here. So hopefully it goes right through. It should. If it doesn't, we have a reason for that. So we go right here. Alright, so that's good. Okay, so now I'm going to move this and move my little construction marks. Now, I'm going to label this A, B, C. As I looked at the test, there were a number of people who had the right idea on what they were doing. But actually, we created two 45 degree triangles. A, B, C is a 45 degrees, 45 degrees, 90 degrees. And actually, the triangle up here is also 45, 90. Matter of fact, if you ever have a square and draw the diagonal, you create two 45, 90 degree triangles. So that is that. And now the last part is the bonus. Here is the bonus. This will be due on Thursday, October 1st. You must do all of your work in order to get credit. You must do long division. And the questions are, how many years in a billion seconds? So I need to see work. I need to see long division. And I want it to the rounded to the nearest year. The second problem is, how many years in a trillion seconds? And I also want this rounded to the nearest year. I need to see all your work. I need to see long division. And it needs to be rounded to the nearest year. This is due on Thursday. So try this, hand it in on a separate sheet of paper.